Welcome to 5.6, inverse trig differentiation, day 1. So we're going to talk about all these different trig functions, and we have to kind of talk about a restricted domain here since they are not one-to-one. So as we're looking forward, and we're talking about sine, cosine, tangent, let's just talk about a restricted domain that we're going to use. So if we go from negative pi to pi for our sine function, that will give us one period there, and we'll have a length of negative 1 to 1, and our angles go from negative pi over 2 to pi over 2. So when we're talking in the unit circle, that's going to put us into quadrant 1 and quadrant 4, because we're going from negative pi over 2 to positive pi over 2. So this accounts for sine and cosine. Continuing on, looking at cosine and secant, we can restrict our domain here from 0 to pi. Our length will still be negative 1 to 1, and again our angles will go from 0 to pi. So if that's the case, going from 0 to pi on our unit circle, that puts us in quadrant 1 and quadrant 2. And again, this accounts for cosine and secant. Moving on to the tangent and cotangent, if we were to look at at the graph, we could go from negative pi over 2 to pi over 2, all right, to include the entire graph there. So the length goes from negative infinity to infinity, but the angle would go from negative pi over 2 to pi over 2. So again, that's going to put us in quadrants 1 and 4 on the unit circle, from negative pi over 2 to positive pi over 2. So just something to keep in mind and recall from pre-calc is that the f of an angle is equal to the length ratio, and f inverse of that length ratio is equal to our angle. So we're going to use that as we go through and we evaluate these next few examples. Okay, so let's evaluate arc sine of negative root 2 over 2. So remember, that's just like saying inverse sine. Okay, so the first thing we're going to do is we're going to let y equal this entire quantity. So y equals arc sine of negative root 2 over 2. So what does that mean? Using our little note from up above is that if y equals the arc sine of that length ratio, then the sine of y equals negative root 2 over 2. And this is where your unit circle comes back into play. So think about, when does the sine of y equal negative root 2 over 2? Okay, so, and again, we're going from negative pi over 2 to positive pi over 2. So we're in quadrants 1 and 4. So that would put us at y has to equal negative pi over 4. So the arc sine of negative root 2 over 2 equals negative pi over 4. I want you to try example B on your own. The inverse cotangent or arc cotangent of negative root 3 over 3. Evaluate that similarly how we did to A. Pause the video, check back when you're done. Okay, so what you should have done is let y equal the inverse cotangent of negative root 3 over 3. So that means cotangent of y equals negative root 3 over 3. So because it's negative, we have to be in quadrant 4. So you can kind of think about it that way. So when is the cotangent negative root 3 over 3? Well, you kind of have to manipulate some things, and I did this side note over here to kind of help us remember that. All right, cotangent is cosine over sine. So as we kind of go through, we could rewrite negative root 3 over 3 as negative 1 over root 3. And then we can think about it as our x over our y. So 1/2 over negative root 3 over 2. And that's going to put us at negative pi over 3. So the inverse cotangent of negative root 3 over 3 equals negative pi over 3. All right, these next ones are just a little bit different. So we're going to look at the cosecant of the inverse cotangent of negative 24 over 7. So first, let's go ahead and focus on this inside portion. We're going to call that theta. Okay? So theta is going to be the inverse cotangent of negative 24 over 7. So that means the cotangent of theta equals negative 24 over 7. So because it's negative, that means we're in quadrant 4. So what we can do is we can draw a right triangle that helps us identify the sides of these triangles, which will then help us find what the cosecant of that theta is actually equal to. So if we're given that the cotangent is equal to negative 24 over 7, we can go ahead and write our sides of our right triangle. So if this is theta, and again, we're in quadrant 4, so this is our x value, this is our y value, right? It's x over y for cotangent. So this has to be positive 24, and this side has to be the negative 7. Using the Pythagorean theorem, we're able to get our hypotenuse as 25. So what we can then do now is, since we have this triangle, we can go back up to this original portion here and say, okay, well, that means we're really finding the cosecant of theta. Well, another way we could rewrite cosecant of theta is 1 over sine of theta. So using our triangle from up above, sine of theta equals negative 7 over 25. We have 1 over that. And then that just simplifies to negative 25 over 7. So this entire quantity, cosecant of the inverse cotangent of negative 24 over 7, is really equal to negative 25 over 7. Using the same idea, I want you to try D on your own, then come back and check when you're done. So similarly to part C, we're going to let theta equal this entire inside quantity. So theta equals the arc cosine of x minus y. So that means the cosine of theta equals x minus y. So now we can use that to label our triangle. If this is theta, the cosine equals adjacent over hypotenuse. Our hypotenuse is 1. We can essentially say that this is x minus y over 1. So that's how we can go ahead and label our hypotenuse here. Again, using the Pythagorean theorem, we're able to get this other leg of the right triangle as the square root of 1 minus x minus y squared. So then we can go ahead and say, well, that means the cosecant of theta, this entire quantity, is really equal to 1 over the sine of theta. And then when we go through and we use our triangle to figure out what the sine of this angle is, we get 1 over the square root of 1 minus x minus y squared. Now we're going to talk about taking the derivative of these trig functions, of these inverse trig functions. So first go ahead and get these 3 down. So the derivative of arc sine of u is equal to u prime over the square root of 1 minus u squared. All right, and then you can get down arc cosine and arc tangent as well. We're going to go through and prove that each of these actually is the derivative. Okay, so let's first look at taking the derivative of arc sine of u. All right, so here we go. Our first proof, if we are looking at y equals the inverse sine of x, or arc sine, then we could go ahead and say, well, that means the sine of y equals x. So we're going to create this triangle here where y is our angle and the sine is equal to x, so that's x over 1. Using the Pythagorean theorem, we get the third side to be the square root of 1 minus x squared. Now we're going to take the derivative of this up above, sine of y equals x. So taking the derivative of the sine of y, we get cosine of y times y prime. Okay, derivative of x is just 1. So getting y prime by itself, we divide by cosine. All right, so we get y prime is really equal to 1 over the cosine of y. And now using our triangle, we can go ahead and work that back in. The derivative is equal to 1 over the square root of 1 minus x squared, which is what we said up above. Okay? Just keep in mind that up above is a u substitution, so the numerator is just the chain rule derivative of what's inside there. Similarly, with the arc cosine and taking the derivative of that, we're going to let y equal the inverse cosine of x, or arc cosine of x. So then cosine of y equals x. Using this and y as our angle, we could go ahead and draw our triangle. So the cosine is equal to x over 1. And then using the Pythagorean theorem, we're able to get the third side of this triangle. Taking the derivative of this quantity from up above, the derivative of cosine is negative sine of y. The derivative of x is 1. Getting y prime all by itself, we're able to get 1 over negative sine of y. And then when we plug that in using our triangle, the sine of y equals the square root of 1 minus x squared over 1. And we get this quantity, okay? Finally, proving the derivative of arctangent of u equals u prime over u squared plus 1. Again, that's for the u substitution portion. We're just going to look at it plain and simple, where y equals the inverse tangent of x. So then tangent of y equals x. Y is our angle. Since tangent is opposite over adjacent, x over 1 is the legs. Using the Pythagorean theorem, we're able to get the hypotenuse to be the square root of x squared plus 1. Taking the derivative with respect to x, you get the derivative of the tangent is going to be secant squared. And then we take the derivative of x, which is 1, dividing both sides. We get y prime is equal to 1 over secant squared of y. Secant squared, we can think of that as, cosine squared, all right? So this is the same thing as saying cosine squared of y. And then using our triangle, we could make that substitution. So 1 over the square root of x squared plus 1, but we're squaring that. And so that's where we get our final y prime or derivative, 1 over x squared plus 1. If you have questions, we'll go through this in class.